Imagine this. Your operators are following procedures perfectly. Your equipment is maintained. Your control system is state-of-the-art. However, the quality of your products is inconsistent. Sound familiar? The hidden villain is often flow measurement. I'm Alana, and after 35 years resolving these exact issues, I can show you what's really happening in your pipes. Give me just 4 minutes to change how you think about flow. At its heart, flow measurement is about answering one question: how much material is moving through my pipe? But there's a critical distinction most people miss right from the start. Are you measuring volume flow, like liters per minute? Or are you measuring mass flow, like kilograms per hour? This single decision affects everything downstream in your process. Here's my first insight after decades in plants. If your budget permits, opt for mass flow when in doubt. Volume changes with temperature and pressure. Mass doesn't. I've seen operators chase phantom problems for weeks because of this simple oversight. Let me walk you through the 4 workhorses of flow measurement and when to use each one. Differential pressure meters like orifice plates are everywhere because they're simple and reliable. They create a pressure drop that relates to flow. They're affordable but require regular maintenance and eat up some energy. Think of it like putting your thumb partially over a garden hose. The restriction creates a pressure difference that tells you about the flow. Magnetic flow meters, or mag meters, are my go-to for most water and conductive fluid applications. They feature no moving parts, no pressure drop, and are incredibly reliable. But remember, they only work with conductive fluids, so no hydrocarbons or gases. Coriolis meters are the premium option. They measure mass flow directly using the Coriolis effect. They're accurate, handle most fluids, and give you density as a bonus. The downside is the cost and size of the product. Ultrasonic meters are non-invasive. They clamp onto the outside of existing pipes. These meters are ideal for retrofits or challenging fluids, but the precise placement of the installation is crucial for precision. Now let's talk about what separates theory from reality: proper installation. This phase is where I see 80% of flow measurement problems. Most flow technologies need straight pipe runs, typically 10 diameters upstream and 5 downstream minimum. Ignore this requirement, and you'll never get accurate readings, no matter how expensive your meter is. Flow meters need a consistent flow profile to measure accurately. Elbows, valves, and other restrictions create turbulence that disrupts this profile. Pay attention to orientation. Many meters need to be mounted in specific positions: horizontal, vertical, or with electrodes aligned in particular ways. Please refer to your manual, rather than relying on what seems convenient for your pipe run. And please double-check flow direction during installation. I can't tell you how many times I've troubleshooted broken meters that were simply installed backward. When your flow readings don't make sense, start with these 3 checks before calling the manufacturer. First, is your pipe full? Partially filled pipes are the #1 cause of erratic readings in liquid flow measurement. Second, verify your scaling in units. Make sure your control system is using the same engineering units as your meter. Third, check power and grounding. Intermittent power or poor grounding can cause inaccurate measurements and erratic behaviors. Remember, the best flow meter is the one that matches your specific application needs. Consider your fluid properties, required accuracy, pressure drop constraints, and of course, your budget. If this video has improved your understanding of flow measurement, please click the subscribe button and give it a positive rating. Please share in the comments which flow application you find challenging, and I may address it in an upcoming video. Until next time, this is Scada and Beyond with Alana. Let's keep things flowing.